Hello, I'm Emily from emilylearning.com, where we partner with students to help them achieve their best results in O and A level math, physics, and chemistry. In this lesson, we'll be talking about rational versus irrational numbers. So what are rational numbers? Well, a rational number is one that can be written in the form A over B, where A and B are whole numbers. And an irrational number is basically the opposite of a rational number. That means it cannot be written in the form A and B, A over B, where A and B are whole numbers. So let's take a look at some examples of rational numbers. So basically, all your integers or whole numbers are rational numbers. So your 3, your 7, your 5. So 3 is basically 3 over 1, right? And 3 and 1 are both whole numbers. So all these whole numbers are considered rational numbers. In addition, right, numbers where you can write it in fractions, like for example 2 over 7, 5 over 9, even mixed fractions like 1 and 2 over 7, this is basically 9 over 7. So this is also considered a rational numbers because you can write it in the form A over B, where A and B are whole numbers. Okay, numbers such as 1.3 or decimals such as 1.25 are also rational numbers, because if you were to take a look, 1.3 is basically 1 and 3 over 10 or 13 over 10. So 13 is a whole number, so is 10. Similarly, 1.25 is 1 and 25 over 100, which is equals to 1 and 1/4 or 5 over 4. So 5 is a real number. 5 is a whole number, and so is 4. Then next, if you look at 2/3 is 0.66666667 and so on. But when you convert it to a fraction, okay, it can be returned in the form of 2 over 3, where both 2 and 3 are whole numbers. So therefore 2/3 is a rational numbers. Now that we have covered so many rational numbers, let's take a look at irrational numbers. So irrational numbers are basically numbers that cannot be represented in the form A over B, where A and B are whole numbers. So example of irrational numbers would be your pi. So recall that pi is 3.14159 blah 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 blah. Okay, it doesn't end. Okay, it is never ending. So this number cannot be written in the form of A over B, where A and B are whole numbers. You can say that, hey, but we have used 22 over 7 as pi in our PSLE or in primary 6 or in primary school. Okay, but this is only an estimation of pi. Okay, it is not the true value of pi, which is this non-terminating decimal here, 3.14159 blah 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 blah. So therefore, pi is an irrational number. Examples of other irrational numbers will be, for example, root 2. So if you were to type into the calculator root 2, you'll notice that it is a decimal 1 point blah 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 blah. It's non-ending. Okay, so you cannot write it in the form of A over B, where A and B are both whole numbers. So therefore root 2 is an irrational number. Now how about root 4? Well, root 4 can be simplified into 2, okay, which is a rational numbers. So therefore, root 4 is not an irrational number. So it doesn't mean that all square roots are irrational numbers, all right? Okay. Then maybe cube root of 5, if you type it into your calculator, it is also an irrational number because it gives you a decimal that is non-terminating, and when you try to convert it into a decimal, your calculator is not able to do so. So this means that it cannot be written in the form A over B, where A and B are whole numbers. Therefore, cube root of 5 is also an irrational number.